Welcome to our session on turning science into business. How do you scale a deep tech or a quantum computing company specifically? For me, it's a massive pleasure to be here with a quantum veteran, if I might call you that way.
Sure.
18 years in the field, immense experience, and I would assume that not many here in the audience share that level of depth. So maybe we can kick off the session today by you explaining a bit about what quantum is, and also what the business opportunity behind that is going to be.
Great, yeah. I'm not going to give a lecture on quantum mechanics, although I recently did. But quantum computing really means that in addition to electricity that we use for everyday classical computing, we also take into use the quantum mechanics, so the quantum phenomena. Basically, we use individual states of energy in the system. So if you go really deep down, the energy is quantized. You can only put certain amount of energy into the system in these discrete levels. And from that follows all this, what you call superposition principle, that actually you can be in two states at the same time. And you do use these phenomena in your advantage in solving computational problems. So it's something fundamentally different. We have fundamentally different operations in our toolbox when we are solving problems. And I feel this is a big revolution in technology in general. And I don't know if there will be such a major revolution anymore. Is there any more resources of nature we can then harness?
Yeah.
That's the question. About the potential for innovation business, I think it's humongous because it's a disruptive technology. Not only we now know already some quantum algorithms of many use cases, like in optimization, encryption, decryption. But I think this technology is so fundamentally different, it will create also its own applications. It's like electricity created computing, computing created mobile phones. Basically, we have now social media, which is created by this development in technology. So similar things will happen to quantum, and I think we are living very, very exciting times.
Maybe one follow-up question here. How long will it take until I have a quantum chip in my smartphone or in my laptop? Or will we ever see that happen?
It is just a matter of time. In fact, you can already buy now a mobile phone with a quantum chip inside. It's not for computing, but it's for random numbers. So there was, I think Samsung has a phone which has a quantum random number generator.
Yeah.
And for computing, it will take some time. Now the way to access quantum computers is through the cloud. So you can even now, from your mobile phone, actually use quantum computing. It's a machine in a big room, and you access it through the cloud service.
I mean, I think for me as an investor, I totally agree with you. The market opportunity here is massive, and seeing that those computers are now starting to get into practice is, I think, insanely impressive. So we get closer and closer to actually unlocking all those opportunities. And I mean, in the end, you're not only a veteran in the scientific field, but also into making the science a reality with your journey at IQM as one of the initiators and founders of IQM. Can you maybe talk a bit about this journey, and specifically, I mean, if we link it back to the topic here, what were the challenges or barriers that you had to overcome in order to actually get to the place where IQM can offer quantum computing in the cloud, or basically get close to offering this at scale?
Well, yeah, I mean, IQM, first of all, big thanks to the great team that was there in the early stages and is there even now. It's a great company and great people, and that's thanks to them for the great success. When we were really kind of spinning out IQM, I don't know if I really realized it, but we always were thinking then when we looked back that we did things exactly at the right time.
Yeah.
I mean, we could have waited for a couple of years to become better in building qubits, but we didn't, because we were ready. the qubits were not ready, but we were ready. And I think that's the sort of, if there are some, possible founders in the audience, that's my kind of advice, that if you think that you have a great team of people and you wanna do it, don't continue doing the scientific research in the university, but just, jump to the startup, because you will see that things will move much faster.
Yes.
So you will be 2x, 4x at least when you do it in a company. You don't have to do these crazy promises in the scientific proposals that we will do something super different, but you will just deliver your milestones, and then you will work and you will do it, and that's the way to get really on a fast pace. So that's something that was not a barrier or a hurdle, but I think it's very important. And well, of course, getting the lead investor, yes. that took us a long time, maybe almost a year, and then another half a year from that to close the investment. So we were raising, or at least I was raising for 1.5 years. Then, of course, along the way, the co-founders joined. So not everybody had to raise for such a long time, but it was a long time.
I mean, we always have one saying that deep tech companies are almost always fundraising, because you always have the next milestone ahead. You need more money to make it reality. And the first round is usually the smallest, where it's still quite, you have visibility on investors that can do it, but at one point you need those hundreds, 200, 300 millions of euros in order to make it work. IQM was very successful in securing it, but fundraising is always a big challenge, specifically because there's the landscape of different quantum technologies is so fragmented that you either really need to be an expert in order to understand the differences and why each different technology platforms are better than others, or you fully rely on what you said, getting something out there. So the quantum computing companies that we see have actually pretty much shifted from selling science to us as investors towards selling products or use cases to actual companies out there. Yeah? So we have moved from the stage where it's purely lab research to a stage where you co-develop together with real-world partners on real-world problems how those algorithms can actually generate money. And this is also something that we love to see in quantum companies. Not only scientific, but also commercial mindsets, commercial excellence to bring the technology out there. Yeah? And I think IQM's website, IonQ's website, this is selling. They are selling. Yeah, it's no longer science or moving out of the lab. So very cool observation, I have to say. Is there any other secret to the success of IQM? I think you know more than 200 people, right? Is that correct, or?
Well, yeah, it started to ramp up pretty quickly.
Yeah.
And some of the if you hire more than one person per week, it starts to be challenging to keep everybody on the same goal and have even people to know their other name, not names of the other people. Yeah. And so that is challenging time if you ramp up so quickly. And so you somehow have to pay attention there, especially. And then if you also change, you take new top-level management team members and people like this, I think those choices are really important. What happens to the culture of the company, and there is no perfect choices, right? I mean, yes. You always have to just do the best thing that you feel in your guts, that this is the best decision, and then you have to correct always because there will be clashes. So when you hire so many people so quickly.
If we maybe take a step back and move from IQM towards your role at Aalto University, what do you consider as the role or responsibility of universities and scientific institutions in terms of bringing the technologies into market in startups and tech companies? What can they do better, or what do you want them to do better in order to really make this a reality?
Right. So now I kind of see that universities, what they are good at least here in Finland, University and VTT, for example, Aalto and VTT are really good at creating the early innovations and then creating startups. And this is what they're very good at, and I think that's what they should keep on doing. Then also, universities, for some reason, they really like to work with big companies, like Nokia or somebody. They really, so that collaboration is also working. But somehow I feel that there is little bit maybe. There could be new roles for universities. Like, what about the inventions that we do that we don't want to, that the big companies don't necessarily care about, or they're not going to really take it into use, and then you don't have the team to make the startup. So there's this kind of a gap I see, and I think there should be some solution of kind of motivating people to do innovations, patent stuff, and then kind of with very little money transfer them to small and medium-sized companies that could then take them into use. So basically help the business also. Like,
I totally agree with you, and I mean we follow the strong thesis that universities should make it as simple as possible for students, researchers to take the science into practice, basically. And I just had a talk this morning with a founder in the space who explained a bit how Aalto University thinks about spinning out IP out of the university, and I think this is really benchmark, Not putting a burden on the company, taking too many shares or revenue share agreements, but making this easy to get the IP into a private entity, I think is also a key differentiator I would like to highlight. Now, if you allow me another switch in topic a little bit, because I mean, in our pre-discussions that stroked me, you underwent this journey with IQM once. And now you've recently decided, even though I don't really know what, to repeat that journey again and become an entrepreneur a second time in the quantum space, despite all those well-funded companies like IQM out there and basically doing amazing things. What motivates you? Can you maybe talk a bit about that company and the gap that you saw there that you want to fill?
Right. So I always want to use my time, for the best benefit of the world, for the society. And what I have, I have been doing now 20 years quantum hardware, and I already actually before that did quantum algorithms a little bit. I started from the theory side. I did my PhD actually in theory, but then 20 years ago I started to do hardware, so experiments, and during these 20 years I've seen amazing development of superconducting quantum computer. And what was mentioned here in the introduction is that actually in the Aalto lab, we have now measured 1 millisecond coherence time for transmon qubits, which is, those are the qubits that IBM, IQM are using in their quantum computers, and this is the longest number anybody in the world has got. 5 years ago, we could not dream about this, but now it's happened, and it has happened again and again if you look back long enough, that they just get better. So to me, it seems that the useful quantum computers, the economically useful quantum computers will be there. But that development, because you have to do quantum error correction, will take about, let's say, 12 to 15 years. That they are really in business use.
At scale.
At scale, at large scale, so that you can run these very complicated quantum algorithms. But I want you guys to be able to use quantum computers earlier. I don't want to wait for 10, 12, 15 years. I want you to use it in 3 years or 4 years' time. So that's why I thought that now it's really important to make new quantum algorithms that can be run with these machines, let's say, in 2027. And that's why I thought that we really need a new company, not to compete with the hardware providers, but actually that can bring customers to the hardware providers. And this is a company focused on new algorithms. So we are still in stealth mode. We have not put anything on social media or talk to press at all. But this will be public very soon.
Are you going to combine that with your research career, or do you think at one point you will have to decide?
Well, first of all, I'm not doing algorithms in the university. So this is maybe a little bit easier case for the university lawyers to figure out. Maybe I can maybe they understand that software, hardware, they're different, and there are different efforts. But I never say I never say that anything is impossible.
Yeah.
So I think, I will just do my decisions based on my best knowledge.
I think it's a fantastic decision. The market timing is there now. You have hardware companies with enough funding to actually provide the computing capacity needed. Go for it. I mean, even though what you describe is very different from what you did at IQM, is there any things in terms of building the firm, building the organization, that you specifically want to do different than you did at IQM?
Sorry, I didn't quite.
Is there something that you want to do differently than you did it with IQM? So is there anything that you, in terms of hiring the team, building the team, scaling the company?
Yeah. So building a full-scale quantum computer is a huge effort. So kudos to IQM team being able to deliver that. It's amazing job they have done. Now, searching and developing new quantum algorithms is like so much smaller sort of thing. Of course, we need a very serious effort on that, but we don't have to hire as quickly as many people.
Yes.
So we can really try to now focus our efforts on a few most promising directions. And then once we found the first killer algorithm, we can make a product and do it like this. So this is in a way, try to really now raise our focus on the most important problem of today.
Yeah, and then make sure that every hire counts towards solving this. Yeah?
Exactly.
I think that makes a lot of sense. Now we've talked a bit about IQM, we talked about full stack hardware and quantum, we've talked a bit about algorithms. Now let's talk about the 15 years from now. What do you think are the types of companies that will succeed or sustainably create value in the industry? How many do you expect to see? What types do you expect to see?
That's a tough one. I don't know, but I can give you different scenarios. There is of course a scenario that, let's say, 2 to 3 big companies, quantum hardware companies, basically go for full stack and they do most of the stuff themselves. There will be still a lot of room for subcontractors, of course. Like for example, Q-Control is a company providing this control software that makes your quantum computer to run better.
Yeah.
And you just install it, the guys come from there, they do their magic, and you get a 4 times better quantum computer. So that's kind of in a way, to me, it seems like a no-brainer that there's room for that kind of companies. Also, like some hardware component providers, like if you really focus on wiring or you really focus on some piece of the hardware that is not the QPU itself, that certainly can be possible. Now there are also companies building the quantum processing units, QPUs, but that's also that's like at the core. So now it's a good question whether that kind of company can keep on providing, whether they can keep up the pace, like to build as good QPUs that they would be then in the useful quantum computers. That's possible, but that's some technology that the big companies like to have for themselves because they think that's really the core.
Do you think we can see a company like Microsoft or at the scale of Microsoft evolving out of all of this?
Yeah. So to me, it's a bit difficult to see now that there would be just a standalone like operating system company in a sense, because the quantum computer operating system is very different from a classical computer operating system. We use classical computers in quantum computers, and however, I think there could be like in a way a company exactly providing this kind of solutions, like connecting basically making the algorithms and connecting the customers through the algorithms to the quantum computer. So in a way, this kind of company I would see, of course, extremely valuable. But yeah, there are certainly many subcontractors that can be there, and it would be also great if there was like companies that you could basically build your own quantum computer, that you would not need to buy necessarily from a full-scale manufacturer. But that's kind of uncertain whether the hardware can be in all of those pieces at the level required.
Mikko, thank you so much. Now I know what to look for in terms of finding my next quantum investment. I hope it was also helpful for you guys if you're thinking about founding something into the space, going into the space. I'm here at the conference, always happy to provide the investor's perspective. I don't know if you're going to stick around for a while to provide your view and ideas. Thank you so much for joining. Really appreciate it.
Right, thanks.